lesson 8.4, graphing f of x equals a times x minus h squared plus k, part 2. Okay, if f of x equals 1/2 x squared and g of x equals 1/2 x minus 4 squared, compare the graph from F to G. Well, what's happening? Look at G of x, okay? Everything's the same except there's a number now inside the parentheses, right, with the x. So we know it's gonna be horizontal. We look at it, oh, it's subtraction, so it's a translation. And it says minus 4, but we know it always has to be the opposite if it's affecting the x. So it's going to be 4 units to the right. All right. Another form for us to remember, it's called vertex form, and it's what we just wrote in the title. So a times x minus h squared plus k. Okay, let's just rewrite it so we can look at all the different parts. So f of x equals a times x minus h squared plus k. So if you see a function given to you in this format, which they will, they're checking to see if you can remember that, oh, this is vertex form, okay? The great thing about vertex form is it's called that because you can immediately see what the vertex is. It's gonna be your H and your K. That's gonna be the coordinate point of the vertex of the parabola. So when it's in this format, it's awesome because you can just see the vertex right away. One thing I want you to notice though, the formula itself already has a minus sign right here. So you only want the H, okay? The H is your X. If this was a plus sign, then it would mean X minus negative something, okay? So I'll show you that in just a second, but this number is going to be the x value of the vertex. The k will be the y value of the vertex. The axis of symmetry, we already know, is the x value of the vertex, right? So it's going to be whatever that h is also. And looking at your a, once again, if a is greater than 0, it opens up. If a is less than 0, it's going to open downward. Okay, just like we learned before, so that doesn't change. All right, let's try one. So we're going to graph g of x equals -2 times x plus 2 squared plus 3. Okay, so a couple things going on here. I want you to think about in here, that's the same as x minus -2. Well, the formula itself has x minus h. So x minus -2 means your h in this case then is -2 instead of +2. And the other thing I want you to think about is, remember, we've always said, if the number is inside the parentheses with the x, it's always opposite of what it looks like, right? So this looks like -h, but we write it as +h. This looks like +2, but we would write it as a -2. So you're just gonna have to get used to that. So if we just look at it real quick, if we just write the formula, a times x minus h squared plus k. So what are your parts? -2 is your a. You can see your x, right? You can see the negative sign. So x minus h has to be -2 then, and k is the 3. Okay, so h is -2, k is 3. See this part out here, the y value does exactly what it looks like, +3, so +3. It's only when it's inside the parentheses with the x that we do the opposite of what it actually looks like. All right, our axis of symmetry is going to be x equals -2, right? Because it's going to be the same as the x value of the vertex, and the vertex then is -2, +3. Okay, all right, let's graph this from what we know. So I'm gonna put my y-axis way over because this is gonna be mostly in the negatives, and I'm gonna go up a little. Okay. So we know our vertex is -2, +3. So it's gonna be right there. It's gonna be right there. 1, 2, 3, yeah. So -2, 3. Now, look at the A. It's a -2, which means it's gonna open downward. So I know this is the top of my parabola. All the other points should be underneath. Okay, we also know that's our axis of symmetry, right? Okay, so if we were trying to graph this, what would be a good idea? Well, you're gonna have to be careful in the vertex form because you're not going to be able to just look at that last number and have it be your y-intercept. This is the one time when you're not going to see a y-intercept in the function. So what else can we do? Well, we can plug numbers in, right? Okay, you can always plug numbers in. So I'm going to plug a -1 in. So g of -1 equals -2 times -1 plus 2 squared plus 3. -1 plus 2 is 1. 1 squared is 1. So it's just going to be -2 times 1. And -2 plus 3 is 1. So another point then would be x was -1. When that happens, y comes out as +1. So -1, +1. Okay, I have 1 point on the right side, so I'm going to get 1 more point on the right side. So I'm going to plug 0 in. So g of 0 is going to be -2 times 0 plus 2 squared plus 3. So -2 times 2 squared plus 3, and -2 times 4 is -8 plus 3 is -5. So when x is 0, y is -5. 0, 1, 2, 3, 4, -5. Okay, we have 2 points on the right side. So now instead of plugging more numbers in, I'm just going to reflect them over the axis of symmetry. This one is 1 away, so I'm going to go 1 away on the other side. This one is 1, 2 away, so I'm going to go 1, 2 away on the other side. Now we have our 5 points, and we can draw our parabola. Okay, what would our domain be? All real numbers. What would our range be? All y values that are less than, right? Here's your top y. All the other y values are going to be less than or equal to 3. All right, I'm gonna have you guys try one. So you're gonna graph g of x equals 3 times x minus 1, 1 squared plus 6. Okay, pause it here. All right, so let's look at this compared to the normal or the vertex form. A times x minus h squared plus k. So my a is 3, my h is 1, my k is 6, right? All right, so what does that tell me? Well, right away we can see our vertex. Again, h is 1, that minus sign is in the formula, the original formula. So that's that. H is 1, k is 6. So my vertex is going to be 1, 6, which means my axis of symmetry is at x equals 1. All right, remember, whatever this looks like in here with the x, it's always just going to be opposite of what it looks like. Okay, let's draw our graph. We'll get started here. I'm actually going to make it pretty tall. And then I'm going to count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay. And then we got our -1, -2, 0, 1, 2. Okay, where's my vertex? +1, +6. Is it going to open up or down? Look at this. +3, so it's going to open up. So I know my other points are going to be up here. Okay, that means this is my bottom, my minimum value, right? Okay, so what would be some good points to plug in? You can go to the right or to the left. I'm going to plug in a +2. So g of +2 equals 3 times 2 minus 1 squared plus 6. 3 times 1 squared is 1, and 3 plus 6 is 9. So when I plug a 2 in, I get out a 9. So 2, 9. And now I'm going to plug a 3 in. 3 minus 1 squared. 3 times 2 squared. 3 times 4 is 12. 12 plus 6 is 18. So when x is 3, y is 18. Okay. Now remember, this is our axis of symmetry right here, right? Okay, so we're gonna now reflect. This was 1 away, so it's gonna be 1 away on the other side. This was 1, 2 away, so it's gonna be 1, 2 away on the other side. And then you can draw, remember it's a U, not a V. Try to curve it at the bottom there. And 2, 9, I graphed that, I knew it looked wrong. 2, 9, and this would then be 0, 9. There we go, much better. Okay. All right. So you find your 2 points and then just give yourself a little thing, then reflect these 2 points over the axis of symmetry. Okay, I'm gonna do a real world problem here. An athlete stands at the 3-point line and shoots. The function f f of x equals negative 0.035 times x minus 12 squared plus 12 represents the path of the ball. And I want to point out right here, sometimes the function will represent the path. So as he shoots, is it going to go up as like a parabola and then come back down? Yes, but sometimes the functions just represent the relationship. So like when we drop an egg out the window, right? That's going to go straight down. So it's not the path of the egg, it's just what's happening in relation to the height and the time. This is the path of the ball, so we're going to see the relation between the distance horizontally and the distance vertically. So that's the difference when it's the path of something. All right, so f of x equals, or sorry, not equals, f of x is the height of the ball in feet, okay? And then x is the horizontal distance in feet also, okay? So that's what I was just saying. That's why it's the path of the ball, because it's how high it goes and how far it goes horizontally. Where when we're just dropping something out the window, it's a relationship between height and time, not height and horizontal distance. Okay, so two different things. All right, so here's the little picture they give you. So we have our little basketball player over here. They're going to shoot the ball. They are 22 feet away from the hoop, which is right here. And the hoop is 10 feet off the ground. Okay, so they're going to shoot the ball. It's going to go on a parabolic path. And we want to know, based on the function that they gave us, will the ball go in the hoop? Okay, so those of you that play basketball, you didn't know that you could be using these quadratic formulas to figure out how to get the ball to go in the hoop. Well, what can we do? Can we check the height of the ball? When x equals 22 feet. Because think about it. So they throw the ball, right? Goes up. But this is my x-axis right here. So doesn't it make sense that this would be, if this is x equals 0, then this is when x would equal 22. And we can just plug 22 in to see if it's going to be high enough to go in the net, right? Okay. So we take our function, negative 0.035, x minus 12 squared plus 12. We see the vertex right away, right? This is in vertex form. So the vertex is going to be 12, 12. What's that mean? Well, after it goes 12 feet, it's going to be 12 feet high. Okay, so 12 feet is going to be a little more than halfway, and it will be 12 feet high. So there's our vertex, and then it's going to come back down, right? Okay, so let's see how high it is when x is 22 feet. So we're just going to plug that in. So f of 22 equals negative 0.035 times 22 minus 12 squared plus 12. We get negative 0.035 times 10 squared. Negative 0.035 times 100 Okay, and when we multiply that, we get negative 3.5, right? Because multiplying by 100 just moves it over 2 places. So we get negative 3.5 plus 12, which equals 8.5. So when x is 22, or when the ball has traveled 22 feet, it will be at a height of 8.5. Is that going to be able to go in the net? Nope. Okay, no, the ball will not be high enough to go in the net. Okay, does that make sense? All right, so it's going to be a parabola, but it's going to come down. This is 10 feet right here, so it'll be probably about right here. All right. Okay, it's not an exact graph, but it'll be too low. It'll miss that net.